Hey guys, so I thought I'd do a quick little video deriving the kinematics equations because I think it's really useful to understand where they come from instead of just blindly believing them. Okay, so let's start by deriving the equation change in x equals v0t plus 1 over 2at squared. And for this derivation I'm going to need two things. I'm going to need the equation v equals v0 plus at. And I'm also going to need this graph of some object, velocity versus time. This can be any object, and the graph can look any way. But if we look at it like this, it's very simple. And as we know, the area under a velocity versus time graph is its displacement. And if you don't understand that, it's because velocity times time is displacement, right? Because velocity equals displacement over time. So velocity times time equals displacement. And the area under this graph is just the velocity times the time. Okay, so let's write down what the area under the graph is and set it equal to the displacement. So change in x equals, so first let's start by the area of this rectangle. And this object, it starts with some velocity, v0, and it ends with some velocity, v final. So the area of this rectangle is going to be v0, which is the height of it, times the width of it, which is time. So v0 times time. And the area of this little triangle here is going to be the height of the triangle, or v final minus v0, times the width of the triangle, which is time, divided by 2. So let's write that down. Plus v final minus v0 over 2 times time. Okay, and remember that what we're doing is we're setting the area under the graph equal to displacement. So this doesn't quite look like this, but if we rearrange this equation to v final minus v0 equals at, right, I'm just moving the v0 to the other side, we can plug at into v final minus v0. So let's do that and let's see what we get. What we're going to get, change in x equals v0t plus 1 over 2, and just moving the 2 out, a t squared. And it's t squared because it times this t and at times this t here, and it becomes t squared. Well, that looks nice, that's one equation. But let's derive another one since we're already here. Let's derive v final squared equals v0 squared plus 2as. And for this equation, we're going to need this equation that we just derived and the v equals v0 plus at equation. And what you might notice about this equation is that it has no time. So to derive it, we're going to need to substitute one time into the other and replace the time with a bunch of different values. So let's isolate for time in this equation. So we can divide by time, we can get v final minus v0, divide by acceleration, sorry, equals time. And when we plug in time here, there's going to be no time in the final equation, because I'm replacing all these times with a v final minus v0 over a. So let's do that then, let's plug it all in. So change in x equals v0 times v final minus v0 over a, right, I'm replacing time, plus 1 over 2a times v final minus v0 over a squared. Okay, well, let's simplify this. And also remember that this s, which I'm writing as s here, is just displacement. So this s and this change in x are simply the same thing. Okay, so let's simplify. And I'll just write equals instead of writing change in x again. v0 v final over a minus v0 squared over a plus, and it's going to be a over 2 times, and I'll square the top and I'll square the bottom, so v final squared plus v0 squared minus 2 times v final v0 all over a squared. And what we notice here is that this a squared can be cancelled out with this a. So this becomes regular a. So we have 2a in the bottom. And I see I have a bunch of a's in the bottom, so let me just multiply both sides by 2a, and it should simplify the equation. So 2a change in x, right, because I still have change in x on this left side, equals 2v0 v final minus 2v0 squared plus, and this just remains the same, right, because I have 2a in the bottom, I'm just cancelling out. So v final squared plus v0 squared minus 2v final v0. Okay, well this is starting to cancel out. We see that we have plus 2v0 v final and minus 2v final v0, so that's just going to be equal to 0. So these things I can cancel out, and we have plus v0 squared and minus 2v0 squared. So that's just going to change to minus 1v0 squared, so let's write it up. So 2a change in x equals v final squared minus v0 squared. Right, because I only have minus 1 v0 squared. Minus 2 plus 1 equals negative 1. Okay, well, this is getting really close. All we have to do is add v0 squared to both sides, and we can get that v final squared equals v0 squared plus 2a change in x. And again, this change in x is just equal to this s, which is displacement. And there you go, that's a derivation. It's pretty simple. I'll box this. And now you can believe the kinematics equations that your teacher just told you to memorize. Okay, thank you for watching.